नमस्कार, म ताराबीर श्रेष्ठ कक्षा 10 का विद्यार्थी भाइ बहिनीहरूलाई यो भिडियो सेसनमा हार्दिक स्वागत गर्दछु। I would like to request all the concerned viewers to watch this video thoroughly so that you can find some interesting knowledge, informations and ideas about the universal law of gravitation and the force of gravity. Today, I am going to begin this session with the citation of a famous saying, hoping that this may encourage you to learn. The saying is, a journey of thousands of miles begins with a single step. अर्थात् हजारौं माइलको यात्रा पनि एक पाइलाबाट सुरु हुन्छ. Dear learners, today we are learning the subject science, class 10, part physics, unit 1, chapter force. Dear learners, let us go to introduce the Newton's universal law of gravitation. There is a interesting story about the Newton's universal law of gravitation. The story tells, once upon a time, Newton was resting under a tree of an apple. Meanwhile, an apple fell onto his head. That incident enforced Newton to think, why did not the apple go to other direction rather than toward the surface of the earth? He began to make several researches and investigations, and ultimately he had precisely defined and formulated the law of gravitation. The law of gravitation holds true for all bodies, whether they are microscopic or massive, placed everywhere in the universe. So that the law of gravitation is called Newton's universal law of gravitation. Newton's universal law of gravitation states that everybody in the universe attracts other body with a force called gravitation, which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. It means the gravitational force of attraction increases with the increment of the masses and decreases with the increment of the distance between their center and vice versa. The gravitational force of attraction has a certain direction, and that force has the direction along with the line joining the centers of the two bodies. This gravitational force of attraction has several results or many consequences, which can be seen in the solar system. That the gravitational force of attraction of the sun causes the revolution of all the planets around the sun. Similarly, the gravitational force of attraction between the planets and the satellites remain revolving around the planets. Another consequence we can take as the tides occur in the ocean and seas of the earth. The gravitational force of attraction of the sun and moon causes the rising of the water level or water surface on the ocean of the earth, which is the consequence of the gravitational force. By Venero, we can verify the Newton's law of gravitation mathematically as follows. Suppose a body A of mass m1 attracts another body B of mass m2 towards its center with a force F. The body B of mass m2 in turn attacks the body of mass m1 towards its center with the same force F, which is shown in the figure given below. Suppose the distance between the center is d, then according to Newton's universal law of gravitation, the gravitational force is directly proportional to the product of masses, which is symbolically written as F is directly proportional to m1 into m2. It is taken as the relation 1. In this relation, the distance is kept unchanged. And the gravitational force is inversely proportional to the square of the distance between their centers, which is symbolically written as F is inversely proportional to d square. It is taken as relation 2. In this relation, the masses are being unchanged. Combining these two relations, 1 and 2, we get F is proportional to m1, m2 by d square, or F equal to capital G m1, m2 by d square. It is written as equation 3, where G is a constant of proportionality, which is known as universal gravitational constant. Vidyarthi bhai bhainaharu, this formula F equal to G m1 m2 by d square can be used for the calculation of the gravitational force produced between any two attractive bodies in the universe if we know the masses of the bodies and the distance between their center. Bhai bhainaharu, you can find this derivation in other tutorial videos related to Newton's universal law of gravitation. My dear students, let's now introduce to universal gravitational constant, which is denoted by G. It is found that the value of gravitational constant G for any pair of masses in the universe is the same. On the other hand, the value of G is independent of the nature of the mutually attracting bodies, terrestrial or celestial, the properties of the medium, rare or denser, in which the bodies are placed. The value of gravitational constant G is 6.67 into 10 to the power minus 11 Newton meter square per kg square, which was first calculated by a scientist Henry Cavendish experimentally by using an extra sensitive device called torsion balance. The value of G is constant everywhere in the universe. That is why it is called universal gravitational constant, which is shown in the figure also. The universal gravitational constant G can be defined as the force of gravitation produced between two bodies of unit mass, each separated by unit distance between their centers. Unit mass means each body contain 1 kg mass and they are placed at a distance of 1 meter, which is shown in the figure. M1 equal to 1 kg, M2 equal to 1 kg, and D equal to 1 meter, that F equal to G. We have F equal to capital G M1 M2 by D square, or G equal to F D square by M1 into M2. In the SI system, the unit of force F is Newton and the unit of distance D is meter M and mass is kg. Then the unit of gravitational constant G is Newton meter square per kg square. This force, that is the universal gravitational constant, is taken as the weak force. It does not affect the other forces. However, it is included in between the two attracting heavenly bodies, and thus We can calculate this force, that is a universal gravitational constant, by using the formula G equal to F d square by m1 m2. Dear students, let us go to introduce the gravity. Gravity. We know that the Earth is spherical like an orange. It may be a great surprise to think how people can stay on the spherical Earth. Nepal and America are located just nearly opposite on the surface of the Earth. A person living in Nepal will have his head towards the sky while standing on their feet on the surface. Likewise, a person living in America just opposite to Nepal will have their head face towards the sky too, while standing on their feet on the surface. The reason behind this effect is the gravity of the Earth. It pulls both of them towards the center of the Earth. We know that everybody falls toward the Earth due to the influence of gravity. Similarly, the Earth is surrounded with the atmosphere due to the force of gravity of the Earth. Rainfall takes place due to the force of gravity of the Earth. So there are several consequences of the force of gravity, that they are also called the effects of force of gravity. You can find these effects in your textbook. If out of two involved bodies in Newton's universal law of gravitation, one body is massive enough, like the Earth or planets, satellites, then the gravitational force is called a force of gravity or simply gravity. Thus, gravity is merely a special case of gravitation in which there is an involvement of a heavenly body. For example, the gravitational force between the Earth and a body near it or on the surface is called the Earth's gravity. Similarly, the gravitational force of attraction of the Jupiter and a body near to it or on its surface is called Jupiter's gravity. The force of attraction, which is the Earth pulls a body towards its center, is called gravity of the Earth or simply gravity. The force of gravity on a body is its weight. That is, how much force does the Earth apply to pull an object towards its center, then the weight of the body will be equal to this force. My dear students, the force of gravity is measurable quantity, which can be calculated by using a certain formula. Let us derive the formula. We can derive the formula as follows. On the basis of the Newton's universal law of gravitation, the gravity of planet or satellite can be calculated. Let the mass of the Earth be m1, denoted by capital M, and the mass of a body placed on the surface m2, denoted by M, as shown in the figure. The distance between their centers can be taken to be equal to the radius r of the Earth. Then F equal to G m1 m2 by d square, according to Newton's universal law of gravitation, where W equal to capital G m1 m by r square, where small m equal to capital m1 equal to capital M, mass of the Earth, m2 is equal to small m, mass of an object, and d equal to r, radius of the Earth. By using this formula, W equal to G capital M small m by r square, we can calculate the weight of an object on the surface of the Earth if we know the mass of the object and the radius of the Earth and mass of the Earth are given as 6 into 10 to the power 24 kg and 6400 kilometer respectively. By Veneru, about the force of gravity, you can find more knowledge from the tutorial videos related to this. By Veneru, now I am going to provide you some home assignments. They are as follows. Number 1, the law of gravitation is called universal law of gravitation. Why? Explain the reason. What will happen to the gravitational force between two bodies when the distance between their center is doubled, is halved? In these both cases, the masses are being kept unchanged, and so the result by calculation. What will happen to the gravitational force between two bodies if the mass of each is doubled and the distance is kept constant? In this case also you have to show by mathematical calculation. Number 4, the masses of the sun and the earth are 2 into 10 to the power 30 kg and 6 into 10 to the power 24 kg respectively. The distance between the centers of the earth and the sun is 1.5 into 10 to the power 7 kilometer. Calculate the gravitational force between the earth and the sun, where the value of G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Number 5, what will be the weight of a body of mass 60 kg on the surface of the earth? The mass and the radius of the earth are 6 into 10 to the power 24 kg and 6,400 kilometer respectively. Value of G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. Number 6, enlist the consequences of gravitation. Dear students, these are some questions that will encourage you to practice it. Now, I'm going to end this session for today. See you in the next session. Thank you very much.